Hi everyone, Molly here from LearnPedia. Today we have Gwen with us, another one of our standout trainees who's shown fantastic progress and performance in our residential design traineeship program. Now, we are going to have a quick chat with her so we get to know about her technical skills and her upskilling journey in Australian residential design and construction field, and also knowing about how she's been implementing the knowledge and skills she's been gaining throughout this traineeship program in the real-life projects she's been working on throughout this traineeship program. So whether you're an employer looking for someone who's ready to hit the ground running, or you're just curious about our training programs, then this video is definitely for you. Gwen, let's start with getting to know you. So the first question, Gwen, is that can you tell us a little bit about yourself?
Hello everyone, I'm Gwyneth. Currently, I'm doing a traineeship with LearnPedia and ANZ Engineers, where I have gained practical experience in Australian residential structural systems and standards. In this role, I was involved in structural analysis and design using softwares like Structural Toolkit and SpaceGas, preparing technical drawings in AutoCAD and making sure that everything aligns with the relevant Australian standards and codes. Before moving here in Australia, I was involved in government-funded projects in the Philippines, mainly in education and public works sector. I handled a range of responsibilities from site evaluation, technical drawing preparation, and site supervision to project coordination.
Thanks for sharing that with us, Glenn. Now let's go over some technical questions. The first technical question I've got for you is that if I assign a new project to you, what will be the first thing that you do before jumping right into the design? Do you have a checklist to follow, any procedures to follow? Can you run me through that, please?
Yep. So before I start any design work, I always make sure that I fully understand the scope of the project. This includes reviewing the site conditions, going through all the key documentations like architectural drawings, soil report, and making sure that I have a clear view of what the project is trying to achieve. Once I have that understanding, I organize everything by setting up a structured folder system, usually a master folder specific to the project I'm working on, with subfolders like architectural drawings, soil report, structural calculations, drafting files, and any other relevant folders, any other relevant documents. Besides that, I also make sure that I follow the company's document control procedures, so everything stays consistent and easy to track. After organizing these files, I run a technical review of the project using a project checklist. This helps me ensure that I'm not missing any key considerations that could impact the design. While there are many factors to consider, I will highlight 3 key elements that I pay close attention to early in the process. These are walls, angle of repose, and tree effect. So starting with walls, I check both the wall type and the clearance above any openings. So each type, either whether brick veneer, double brick, timber stud, or single brick, comes with different lintel requirements. For instance, a brick veneer walls usually requires a separate lintel for the timber side and for the brick side, while for a double brick wall, this might require a T-lintel, PFC and plate, PFC and angle, or UB or UC, depending on what does the project requires. For the clearance above any openings, if the space above an opening is tight, say 200 mil, I need to make sure that the lintel I specify fits properly on the space provided and doesn't stick out of the wall. So moving on to the second consideration, which is angle of repose. When it comes to angle of repose, it often becomes a concern when working near neighboring property or near easements with underground pipes. So as the designer, I need to specify a footing design that won't undermine or be undermined by the adjacent structures. The goal is to make the footing deep enough to stay outside the critical angle of repose to maintain stability and avoid future issues like soil collapse or settlement. Lastly is the tree effect. Trees, whether existing or proposed, can have a huge impact on the soil, particularly on reactive clay. This is because tree roots draw moisture from the soil, which leads to ground movement over time.
Perfect. All right. Now let's move on to the second technical question. When you're designing barriers and joists for a subfloor system, before finalizing the sizes for these elements, what else do you consider in your design besides just the structural aspect?
So before I settle on the sizes for the barriers and joists in a subfloor system, one of the first thing I check besides structural adequacy is the ground clearance. The NCC, specifically Year 2022 Table 6.2.1b, sets a minimum clearance of 150 mil from the underside of any timber element to the natural ground, and this is for standard conditions. But if the site is in a termite-prone area, that minimum increases to 400 mil. That's a significant difference, and it really matters because if the clearance is too tight, there's a risk of moisture issues, termite problems, and long-term damage to the timber. So right from the start, I review the site conditions and make sure that I'm working on the correct standard. Once I've reviewed the clearance requirement, I move on to the architectural constraints. Most of the time, the architect has already specified a total depth for the subfloor, and that's often locked in to align with the finished floor level and ceiling level. These are usually fixed due to planning requirements like building height limits or overshadowing. So there's very little flexibility in terms of playing with sizes. If this is the joist and this is the bearers, one approach I use is to run the joist into the sides of the bearers, putting them on top. That way, I can reduce the overall depth and help bring the subfloor back within the limit. Another important thing as well is to make sure that the timbers are properly treated. This is because subfloors are constantly exposed to moisture and potential termite activity. So making sure that you are using a well-seasoned and treated timber is very important.
Thank you so much, Gwen, for a thorough answer. Now, let's move on to the third question. So let's say you're working on a new residential build with a timber truss roof system. How do you usually approach that part of the design? Like, a design with timber truss roof system. How do you approach that project?
When I'm working on a residential project with a roof truss system, one of the first thing I consider is whether the trusses will be hidden or exposed. Mm-hmm. If they're hidden, they're typically designed and supplied by the manufacturer. But if they're going to be exposed, I will be in charge of the design, making sure that I balance both the aesthetic and the structural requirements. In the early stages, the exact location of the girder trusses isn't always available. So a practical approach I use is to roughly position them about 1/3 from where the two hip lines meet. This is not exact, but it gives me a reliable starting point to design the supporting elements like lintels and beams. Since this is just an assumption, I always include a note on the drawings asking the builder to let the office know if the actual truss layout differs from what is on the drawings. That way, if there's any adjustment, I can double check the affected members before the construction begins. This is especially important because girder trusses are heavily loaded trusses. So if a lintel was designed for a standard roof load, but it ends up supporting a concentrated load from a girder truss, it may exceed its capacity, compromising both the strength and deflection limits. If this is overlooked, the lintel can deflect more than expected, transferring additional load to the doors and window frames below. While this might seem minor at first, this can lead to jamming or distortion of the frames, potentially resulting to costly repairs over time.
Done. So now on to the last question, which is about your career goals. What is your career goal, Gwen? What is your mission in your career? Where do you see yourself a good fit? And how do you think you can add value to the team you'll be joining?
I'm currently looking for opportunities in structural or civil engineering, particularly within the residential infrastructure or mixed-use developments here in Australia. As I deepen my knowledge of Australian building codes and construction practices, I'm especially interested in roles that involve structural design, site supervision, or quality assurance. Through my experience and training in Australian residential constructions, I've developed a solid understanding of local compliance requirements and industry standards that has given me the ability to approach the project with both technical accuracy and practical understanding of what really happens on site. So having worked on both office and on-site environments, I've gained a broad perspective of how the projects come together, and it made me more aware of how design choices impact what happens on the field. And as a result, I've become more proactive in spotting potential issues early and coming up with practical and buildable solutions. Beyond that, I am someone who values continuously learning, and I make a point of keeping my skills up to date so that I can bring relevant knowledge and fresh ideas to whatever project I'm working on.
Fantastic. I've seen your commitment, Gwen, to upskilling and really doing your absolute best throughout the traineeship program. If you're a hiring manager watching this video or an industry professional and you want to connect with a job-ready engineer like Gwen, feel free to reach out to her. Thanks, Gwen.
Thanks, Molly.